Welcome to The Explainer. Today, we're going to dig into a really powerful idea called Bayesian Epistemology. Basically, it's a way of thinking about belief not as some kind of on or off switch, but more like a dial, a spectrum of confidence that we can adjust as we learn new stuff.
All right, let's just jump right in with a puzzle. It seems super simple on the surface, but it totally breaks our everyday idea of what it means to believe something. So, picture a fair lottery, 1 million tickets, just one winner. Now, does it seem rational to believe your ticket is going to lose? Yeah, of course. The odds are 1,000,000 to 1 against you. And you'd feel the same way about ticket number 2 and ticket number 3, and so on, right? But if we follow that line of thinking, where does it actually get us?
To really see the problem here, we need to look at how we normally think about belief. A lot of the time, we treat it like a light switch. It's either on or it's off. You either accept something as true or you reject it as false. There's really no in-between, no dimmer switch.
And this is exactly where that on-off switch model completely falls apart. Look, if you believe ticket number 1 will lose and ticket number 2 will lose, and you believe that for all 1 million tickets, then you are logically committed to believing that no ticket will win. But hang on a second. You know that's false. You know one ticket has to win. So you've started with a bunch of perfectly reasonable beliefs and ended up with a conclusion that's completely contradictory. That's the lottery paradox. And it shows us that this simple model of belief just isn't up to the job. So how do we fix this? Well, the philosopher Rudolf Carnap came up with this brilliant analogy using temperature. He said, our simple on or off belief model is like trying to describe a room as only hot or cold. Sure, it's useful for a quick take, but it misses all the nuance, doesn't it?
We can get a little more specific, right? We can start comparing things. We can say, well, this room is warmer than that room. This gives us more information. It lets us rank things. And it's the exact same with our beliefs. We're almost always more confident in one thing than we are in another.
But the real breakthrough, the most powerful way to talk about temperature, is to use a number on a scale, a quantitative concept, 22 degrees Celsius. That doesn't just tell us one room is warmer, it tells us how much warmer it is. And that is the level of precision we need to solve our paradox.
And that brings us to the big idea here, credence, which is just a fancy term for a degree of belief. Instead of that on-off switch, think of it as a dial that goes from 0 to 1. 0 means you are absolutely certain something is false. 1 means you are absolutely certain it's true. And everything else is somewhere in between.
And this is really the key. This whole framework lets us capture nuance that the old model just completely misses. I mean, think about it. A physicist might say she believes her car brakes will work. She might also say she believes nuclear fusion is the future. But her credence, her actual degree of belief, is completely different. She bets her life on those brakes every single day. Her credence is practically 1. Her belief in fusion? It's real for sure, but her confidence level is just much, much lower.
Now here's what makes this so incredibly powerful. For these degrees of belief to actually be rational, they can't just be random feelings you pull out of thin air. They have to follow the strict mathematical rules of probability. And that's the secret sauce that keeps our thinking consistent and saves us from falling into paradoxes.
The thing is, our natural intuitions are often really bad at probability. Let me show you what I mean with a classic experiment from the psychologists Tversky and Kahneman. They gave people this short description of a fictional person named Linda.
Okay, so after reading that description, people were asked a simple question. Which of these is more probable? Is it more likely that Linda is a bank teller, or that Linda is a bank teller who is also active in the feminist movement? Now, the huge majority of people pick option 2. It just feels right, doesn't it? The story fits. The only problem is, it's logically impossible.
And you can see exactly why right here. It's a basic rule of probability. The group of feminist bank tellers is by definition a smaller group inside the bigger group of all bank tellers. Something can't be more likely to be in the small box than in the big box that contains it. But our intuition, our love for a good story, tricks us into making a fundamental error in logic.
So being able to put a number on our beliefs is cool. But that's not even the best part. The real magic of this whole framework isn't just describing what we believe right now, but giving us a rational way to update our beliefs when we encounter new evidence.
So let's make this practical. Imagine a biologist is studying a species of fish. She wants to know if the gene for blue fins is dominant or recessive. She has no idea, so she starts out completely neutral. A 50-50 credence, a 0.5 degree of belief for each possibility. Then she goes out and collects some data. Just one piece of data. She catches one fish, and that fish has blue fins. So how should this new information change her mind?
This is where Bayes' theorem comes in, and it's like a mathematical engine for updating your beliefs. Think about it for a second. If the blue-fin gene is dominant, you'd expect to find more blue-finned fish. If it's recessive, you'd expect to find fewer. So the observation of a blue-finned fish is stronger evidence for the dominant hypothesis, and the math of Bayes' theorem tells her exactly how much to turn that dial. Her confidence in the dominant theory jumps from 50% all the way up to 75%. She's not certain yet, but her belief has shifted in a perfectly rational way.
So let's just recap the journey we've been on. We started with this rigid, black or white, on or off model of belief that frankly breaks when you look at it too closely. And we've replaced it with this flexible, dynamic framework that not only solves those paradoxes, but gives us a logical, powerful engine for changing our minds when we learn something new.
And look, this isn't just some abstract philosophical theory, it's a tool for thinking better. It encourages all of us to be a little less certain and a lot more curious, to constantly be adjusting our mental map of the world as we learn more about it. It asks us to treat our beliefs not as treasures to be defended, but as dials to be tuned.